Hello, sixth grade. I hope you and your family are doing well. This is my first try at doing a video and teaching a new concept in math. So let's see how we do. We are on lesson 11.2, which is on addition and subtraction of equations. I posted a couple videos the past 2 weeks that kind of went over this. So hopefully this is not totally new to you. Let's hit this review first. We need to know the difference between an expression and an equation. All right, 3x plus 4. Notice that there is no equal sign, so we would call this an expression. All right, an equation, 3 plus x equals 5, since there is an equal sign present, right, that is what mathematicians call an equation. Remember, the word equation has the word equal kind of hidden inside of it to remind you. All right, the next thing that we're going to go over is a major algebra rule. And I have listed it here in orange. Says whatever you do to the left of the equal sign, you do the same thing to the right of the equal sign. So let me go over these properties, all right, that explain this. All right, here's our first example. It's called the subtraction property of equality. It is on page 304 if you want to look at it. I just did a simple example without any variables in it. If we have 3 plus 2 on the left side of the equal sign, and we have the number 5 on the right side of the equal sign, the two sides are equal. So that's why we have the check mark and we say that it is true. If we subtract 2 from the left side, and also subtract 2 from the right side. All right, the 2's will cancel out on the left side, and we're left with 3. And then on the right side, we do 5 minus 2, which also equals 3. 3 equals 3. Yes, that is a true statement, right? That is what they mean by subtracting the same number from the left and right side of an equation, right? It will change the value of the equation, but it will still remain true. All right, the next example is with addition. The addition property of equality is on page 305. Here's a simple example. 7 plus 3 equals 10. If I add 4 to the left side of the equal sign and add 4 to the right side of the equal sign, 7 plus 3 plus 4 equals 14. 10 plus 4 also equals 14. 14 does equal 14, so yes, that is true. Right, so we've just proven that whatever you do to one side of the equal sign, if you do the same thing to the other side of the equal sign, that your equations will remain true. Now, let's do an example that does not. This does not follow algebra rules, right? We start with 6 plus 1 equals 7, which is a true statement. This time, I add 2 to the left side of the equal sign and do 6 plus 1 plus 2, which equals 9. To the right side of the equal sign, I do 7 minus 2, and I get 5. All right, 9 and 5 are not equal, right? We would say they're not equal, so this is not true. So this is an example when we did not do the same thing to both sides of the equal sign, right? And this is one of our basic building blocks of algebra when we work with equations. All right, let me turn the page. So what we are practicing today is the major goal of algebra, which is to solve for the variable, which means that we want to get the variable all by itself. All right, today I'm going to be giving you 10 practice problems where we're using addition and subtraction in the equation to get the variable by itself. All right. I will do 3 practice addition ones and 3 practice subtraction ones with this video. Right, and then you will want to click on the document that's attached to try some on your own. All right, but here's the first one. We'll start real simple with addition. Okay, if we do y plus 2 equals 8. All right, the goal of algebra is to get the y by itself. Now, I know when you look at this, you would say, okay, y equals 6, because we know 6 plus 2 equals 8. But we want to start solving these problems algebraically, so we're going to use our properties that we just talked about. If we want to get y all by itself, that means we want this plus 2 to disappear. Right, now the opposite of a plus 2 is minus 2. And if I do subtract 2 on the left side, I must subtract 2 on the right side. I'm going to draw my equal sign. Okay, now I'm going to solve for my left side. If I've got a plus 2 and a minus 2, these are going to cancel out. They're going to turn into 0, and I'm going to bring my y down. Now I'm going to solve the right side. 8 minus 2 equals 6. All right, and here is our answer, y equals 6, which we already knew, but now we know how to solve it using the rules of algebra. Okay, let's do another example with where we have an equation with addition. All right, let's change the variable, and we'll put the number first this time. 4 plus x equals 10. Okay. Now, we already know that x should be 6, right? But let's practice using algebra. Remember, the goal is to get the x all by itself. So we want to turn the 4 into a 0, right? So that the x is by itself. So we are going to do the opposite of a positive 4. We are going to subtract 4. Whatever we do to the left side, we must also do to the right side of the equal sign. Draw your equal sign in. 4 minus 4, see how those 0 out, become 0. We bring our x down. Okay, now our x is all by itself, which is what we wanted. And 10 minus 4 equals 6. That is our answer to our second problem. Okay, let's do one that has a decimal point in it, all right, because you're going to have some of those on your homework, okay? So let's do z plus 1.2 equals 5.4. All right, this one is not as obvious as the other two because it involves a decimal point. We want z to be all by itself. So if z is to be by itself, we must get rid of the 1.2. So we are going to subtract 1.2 on the left side, and then we need to do the same thing on the right side. Draw your equal sign in. 1.2 minus